Good day, learners. In this video, we'll be focusing on introduction to galvanic cells. So in galvanic cells, in these cells, this is how we see the galvanic cells. They are always given into two containers. These two containers, they are joined by the salt bridge. You will have your electrodes, your electrode A and your electrode B. Now the first thing to do is to identify the anode and cathode. One of these electrodes will be an anode and the other must be a cathode. Now how do we now tell which of these is the anode? We use three things. If you are given the names, you use table 4b. If you are given names, use table 4b. If you are given names, we use table 4b. Times when you go to the exam, you'll find that you are told that this is zinc, and you find that that one is copper. So you go to table 4b. Now this is how we use table 4b. The top half reaction on table 4b will be this is your table 4b, by the way. The top half reaction on table 4b will be your anode. We say the anode must be top half reaction. Anode, remember A comes first before C. So your A is your top half reaction. Your anode is the top half reaction. The cathode is the bottom half reaction. Now we go with these examples that we have. We want to identify the anode and the cathode between these two electrodes that are given. You go to table 4b, you check from the top. We're looking for zinc or copper, the one that you find first at top. You see, zinc is there at the top. It means that zinc will be our anode in this case because zinc is the top half reaction. So we agree that zinc is the anode. Zinc is the anode and the Cu will be the cathode according to this example. Then in here, if zinc is the anode, it means that zinc undergoes oxidation. The oxidation takes place at the anode. If zinc is the anode, it means that zinc undergoes oxidation. And if zinc undergoes oxidation, it means that zinc is a reducing agent. And we go to the other side. Cu is the cathode. If Cu is the cathode, it means that Cu undergoes reduction. If Cu undergoes reduction, it means that Cu is the oxidizing agent. So I said in this case, we gave you the names. If you are given the names, we use table 4b. The top half reaction is the anode and the bottom half reaction will be the cathode. Now let's assume that you are not given the names. And instead of them giving you the names, they give you negative and plus. And they say identify the electrode A or B. If you are given signs, we use government of ANCs, the president. This means that in a galvanic cell, the anode is always negative and the cathode is positive. So we can tell from the government of ANC that In a galvanic cell, that anode is always negative, cathode must be positive. It means that A is the anode, and B, because A is negative, it means that A must be the anode, and because B is positive, it means that B must be the cathode. At times, they won't give you the signs, and they won't give you the names. They will give you the direction of electrons. They will give you the direction of electrons. So just put that arrow there, which is for direction, and they put a small e there. That means that in the external circuit of a galvanic cell, the electrons, they flow from anode to cathode. So the electrons in the external circuit of a galvanic cell, they always flow from anode A to C, anode to a cathode. These are the three methods that we use to identify the anode and the cathode. Remember, before you can answer the questions, we need to first identify the anode and the cathode. So we said point number one, if you are given names, if they tell you that this one is zinc and the other one is copper, you use table 4b. If they give you signs, about plus or minus, you use government affairs, is the president. If you are given the direction of electrons, in the external circuit of a galvanic cell, the electrons, they always flow from anode to a cathode, which means that A will be a cathode if the electrons flow to that direction. Means that this one has to be an anode and that B must be a cathode. Okay, now this is what happened as the reaction is taking place. In here, so you place these two electrons. Remember we said this one is zinc and that one was copper. This one is copper. As the reaction is taking place, it means that if the zinc undergoes oxidation, it means that zinc is losing the electrons. It's more like copper is taking away electrons from zinc. As zinc is losing these electrons, remember in the solution we have Zn2 plus. We have about Zn2 plus in the solution. Zn2 plus. Even in here we have Cu2 plus, Cu2 plus, Cu2 plus. As the reaction is taking place, if zinc donates 2 electrons, say 2 electrons, given away to copper, it means that, remember this is zinc, right? There we have the Zn in the surface of this metal. Just make an example so that this becomes practical. If zinc gives away electrons, 2 electrons to copper, it means that one of these Zn from the surface of this metal, it goes off. Now zinc is reducing a bit. You see that there's a gap now. Now this is what will happen. That Zn can no longer come in here. It now goes out to the solution. That Zn will become Zn2 plus because it's in need of the 2 electrons that it gave away to copper. When these 2 electrons reaches this side, we have the 2 electrons that are entering this other side of copper. Remember these ones, they are running short of 2 electrons. Now once they see that, oh, there are 2 electrons that just entered, one of these will jump and join with these electrons and they will form a solid, which is Cu. Meaning that this side, it will gain a bit of copper there because it has gained the electrons. One of these will join, meaning that Cu will be formed. There's a Cu now that was attached additionally on this Cu copper. As the process continues, the zinc will continue to lose itself, decrease and decrease and decrease. As a result, towards the end of this reaction, you find zinc becoming tiny and tiny, and you find Cu becoming, gaining the mass. So you find your Cu now gaining in mass. So we say that in the anode decreases in mass during the reaction. decreases in mass, and the cathode increases in mass. Okay, so these are the exam type questions. They can ask you to tell which one of these will be increasing in mass and it will be which one will be decreasing in mass. We know that the anode is always decreasing in mass and the cathode will always be increases in mass. We move on to the next part. So we are done with this one. We move to the next part. At times they will ask you of the functions of the salt bridge. Remember I said this guy is the salt bridge. Salt bridge. Okay. One of the functions of salt bridge, we say that it separates the two half cells, or it completes the circuit, or it balances the electrical neutrality. So those are the three functions of the salt bridge. At times they will ask you to write the cell notation. Cell notation. Cell notation. The cell notation is always given as anode, cathode on the other side. Presenting that cell, but in this form. Doing the same thing in there, but in this form. So now, the anode must always be on your left-hand side. This is how you do your cell notation. You always have your electrode, your electrolyte, slash, the double slash in there. Remember, this is change in phase, and these double arrows are for the salt bridge. We have electrolyte, and electrode. So according to this cell, remember we said the anode, remember we said zinc is the anode, according to that cell that we have there. We say zinc is the anode. It means that the electrode of zinc will be just a Zn. That is the electrode. Remember, an electrode is that a solid that is dipped into solution. So we just write Zn. The electrolyte is this solution, the liquid that conducts electricity. So we have Zn, Zn plus. Then we have double arrows. The electrolyte on the other side, we are now on that cell, on cell B, right? That half cell B. So in there we have Cu2 plus. Slash, the electrode will be Cu. This is how we do the half cell of a galvanic cell. At times, they will ask you to balance the equation. This is how we balance the equation. You always write your anode and you follow by cathode. So in this case, we have our Zn. We have our Zn. Your Zn will be, okay, so I want to be accurate. It comes with 2 plus, yeah, that's according to the example that we used. Say Zn is here. Okay, yeah, it's okay. So we said we always start with Zn. So you have Zn. We have Zn. Let me write it the way that we found it in table 4b. Okay. On table 4b, you find your anode in this form. You find all of them in this form. Zn 2 plus 2e into, there's a double arrows in there, and you have Zn. When you write your anode, when you take your anode from table 4b, if they say write down the half reaction that takes place at an anode, you always write the anode from right to left, from table 4b. This is our anode. Remember we said this was the top half reaction that we saw from table 4b. It means that you write this from right to left. So you have Zn into, instead of double arrows, you now use a single arrow. Into Zn 2 plus a 2e. Then we come and write the cathode. The cathode is on the other side. Your cathode on the table 4b, these appear like this. There's a double arrows and you have Cu. The cathode, you write it the way it is on table 4b. It comes as Cu2 plus a 2E. But instead of using the double arrow, you use a single arrow. This is the anode, this is the cathode. When you write your anode, you write it from right to left. Your cathode is always left to right. So when you balance your equation, you start with your anode, followed by the cathode, then you balance. Balancing the equation means that you balance the electrons. If we find these electrons the same, it means that now the equation is balancing. We can cancel out the electrons and we write the final equation that we have. This will cancel to that because the electrons are balancing. What are we left with? On the left hand side, we are left with Zn plus a Cu2 plus. On the right hand side, we are left with Zn2 plus a Cu. That is your balanced equation. Let me make this an example. If it happens that, I'm making an example now, we managed to balance the equation. Okay, let me do it aside. So here the equation balanced, we cancelled the electrons. The equation balanced, the electrons were the same, so we cancelled the electrons. So now let's do this example, right? Let's say this is just an example. Let's assume that you were given something like this. I'm just making an example. I know this doesn't exist. So we have 6E into this side we have Cu 2 plus 2E into a Cu. I'm just making an example, right? We are done with the first one, which was accurate. Here I'm just making an example. So now do you notice that the electrons, they are not balancing? If the electrons are not balancing, this is what we do. You take this number of your electrons, you multiply with on the top equation. What do we have in there? We have 6E. It means that underneath we must multiply by 6. That's how we balance the electrons. Multiply everything by 2, we're going to have 2Zn into 2Zn, 2 plus a 12E. We go to the second equation, we have 6Cu2 plus as 12E, which will be equals to a 6Cu. You see the electrons now, they now balance. I see 12 electrons on this side and 12 electrons on this side. This is how we balance the electrons. Then you cancel and you write your final answer. Right? We move on. There are standard conditions in which the galvanic cell operates. There are standard conditions in which the galvanic cell operates. The galvanic cell operates under these conditions. The temperature must always be equals to 25 degrees Celsius. The concentration must always be equals to 1 mole decimeter cubed. The pressure must always be equals to a 1 atm. These are the standard conditions for the galvanic cell. Right? The last part, we've balanced the equation, standard conditions. I think I'm missing something. Balance the equation, standard equation. There's a part. Oh, calculating E cell. Calculating E cell. If you are asked to calculate the E cell, or rather the EMF, means that the formula is given at the back of the question paper. You always say E cell is equals to E cathode minus E anode. And that's it. You go to table 4B. These numbers here, these are the numbers that you use. So if you are calculating the E cell for this, where is my zinc? Zn is there. Zinc is negative 0.76 minus. On this side, E anode, we said copper is the anode. Let's look at Cu2 plus. Our Cu somewhere in here, there is Cu. So I have negative 0.34. So because this cell, I just created it on my own, see now, I'm getting a negative. When we add this, we'll get a negative, which is not allowed. Every time when you calculate your E cell under galvanic cell, your E cell must always be positive. It must come out as positive. So E cell must always be a positive greater than 0. Should you get a negative like me, means that something is wrong. Remember, this was just an example, right? I created my own cell. Thank you.